We're going to look at factorising, and in particular factorising an expression. This is a method from first principles, so not the quickest method, but will give you a good understanding of what we mean when we ask you to factorise an expression. And of course, once you're confident, then you can begin to jump steps, but I would strongly recommend that you have a good understanding of what's going on, and one way of understanding is by using this method that I'm about to show you. Now, what I've found is if I was to ask someone what do I mean by a factor, often they have a little bit of difficulty, but if I gave them a number 15 and asked them what the factors of 15 were, often they have a much better chance of success, and they tell me 1, 3, 5 and 15 are factors of 15. And so, whilst I'm not going to use a strict mathematical definition, they are all things that divide into 15. And if we think along those lines, we'll be on the right tracks for what we're about to look at. What I would say is there's a certain assumed knowledge for you to be able to get the most from this video. Firstly, you've got to be good with prime factor decomposition. If I give you a number, you've got to be able to write it out as a product of its prime factors. And one way of doing that is using the prime factor decomposition tree. So if you don't know how to do that, you'll need to go away and look at that. To give you an example here, if I was to write out the number 30 and ask you to write that out as a product of its prime factors, you should be able to tell me that 30 can be written out as 2 times 3 times 5, and this is a product of its prime factors. These are all prime numbers, so you've got to be able to do that. The other thing you need to know is basic indices. So I'm not talking at this point the rules of indices, but you need to certainly know that, for instance, x squared is really the same as x times x, or for instance xy cubed is the same as x times y times y times y. So you do need to know that, be proficient with really what this index actually means, and if you're not sure about that, you'll need to go away and revise that, and hopefully I'll have another video shortly. So moving on, we're going to look at the technique that I'm talking about, and the first step is to write out the numbers in terms of their prime factors, and any symbols write out in full without indices. So let me give you an example. This I would write out 4 in terms of its prime factors, 2 times 2, and we know in algebra anything next to each other is a times, but instead of x squared I'm going to write it out in full, x times x. And I'll move on to the next term. So this is no different to 4x squared. It's simply 4x squared written in terms of its simplest building blocks. And then I'll add to that this second term, now 6. The prime factor product of that is 2 times 3. And again, anything next to each other is a times, and we can just write x here. There's no index, so it's just x. And again, as you'll see, this is still 6x, 2 times 3 times x. I've just written it in terms of its most basic building blocks. Now, the reason this is so useful is when we factorise, we're looking for things that are a part of both terms, or all the terms, things that appear in both. And the great thing about this is that I don't need to do any calculations in my head. In fact, I don't really need to do any thinking at all. I can just look and see what appears in both terms. So I can see there's a 2 appears in both. But there isn't a second 2. There's only one 2 that appears in both. I can see moving along there's an x that appears in both terms. But again, there isn't another x, so I've only got one pair of x's that I can pair off. And the 3, there's only one 3, so there isn't a 3 doesn't appear in both terms, so I can't pair that off with anything. So the thing that appears in both terms is a 2 and an x. And so I can write this outside the brackets because it's going to apply to both terms. So instead of writing it out twice, I write it out once, and because I'm using brackets, it's going to apply to both terms within the brackets. And this is the great thing now. Again, I don't do any thinking, I simply look at what's left. In the first term, there's a 2 times an x plus, and there's a 3. So you can see really all I've done is written what applies to both, the 2 and the x, and then just everything else has been written 2 times x plus 3. Finally, this is correct, but I'm going to simplify it. So I'll simply write 2x, and again with algebra anything next to each other means times, and we're done. It's always good practice to check, and often people are much better at expanding a bracket, expanding brackets and multiplying out brackets than they are at factorising. So again, what you should do is expand this out, and you should get back to where you started. Here's another example, and I'm going to use exactly the same method. I'm going to write each term in terms of its basic building blocks. So to start with, I'll write the number in terms of its prime factors. So 8 would be written as 2 times 2 times 2. And again, because we're next to it, it's a times. And instead of x to the power of 3, again, I'm going to write it out without any indices. I don't want to use indices, so I'm writing it out in full. So it would be x times x times x, and finally it's times a y. And you can see whilst this is written here in terms of its basic building blocks, it's exactly the same. It's still 8x cubed y. It's just written in terms of its basic building blocks. And then I've got my second term, I'm adding to that my second term, and 12 written in terms of its prime factors is 2 times 2 times 3, and here I'm timesing that by x squared, but again I'm not using indices, it's in terms of its basic building blocks. So instead of x squared I write x times x, and finally I'm timesing it by a z. So it's important at this stage that you can see this is exactly the same as 12x squared z, but just written out in terms of its basic building blocks. And now I look at what appears in both lists, in both this term and also appears in this term as well. In other words, what appears in here and here. And by writing it out this way, as I've said, I don't need to do any thinking or calculations in my head. I can just physically see. So I can see I've got a 2 that does appear in both lists, and in fact another 2 appears in both lists, but not a third. I have an x that appears in both lists, and a second x appears in both lists, but not a third x, and y doesn't appear in both lists. And if I was just to check, here I can see Z doesn't appear in both lists, 3 doesn't appear in both lists. So I'm confident that what appears in both lists is 2 times 2 times x times x. And we can see here we've also got 2 times 2 times x times x. So that's what I'm going to write outside the brackets. And really, you can think of this as me saving myself ink. Because it applies to both, I'm only going to write it out once. And then inside the brackets, I just put in what's left. I've already, for this term, got the 2 times 2 times x outside the bracket, so it's just what's left that I put in. So it's 2 times x times y. So that's the first term, and now I add to that the second term, and here we can see the only thing that's left over is the 3 times the z. And that's it done. This is correct, but clearly not in our conventional form or our simplest form. So what I'll do is just simplify this now. So we're doing the reverse. We wrote this initially in terms of the basic building blocks, but now we're going to simplify this so it's more concise. So instead of 2 times 2 I'll write 4, and instead of x times x I'll write x squared. And again, we don't put the times signs or the multiplication signs in algebra, so this will just be 2xy plus 3z. And again, it's good practice to always multiply this out and be sure you get back to the beginning. So that's it. As I've said, this isn't the quickest and the simplest way, but it is definitely a way that gives you an understanding of what's really going on when we factorise an expression like this. As you have gained an understanding and get good and proficient, you may well be able to jump steps, but it's important that you understand and can do this first.